You know, building distributed applications can feel like a total bait and switch, right? We chase after this promise of incredible speed and agility, but we end up tangled in this messy web of complexity. Things like service discovery, state management, resiliency, it can be a nightmare. Today, we're going to look at a way to untangle that web and finally reclaim the promise of microservices. And this is the core question, isn't it? The one that so many development teams are wrestling with. We broke apart the monolith to gain speed. But did we just trade one kind of complexity for another? Maybe even a worse one? For a lot of us, the answer has been a big, frustrating yes. But here's the good news. It doesn't have to be that way. There is a better approach.
So, to really get why the solution is so cool, we first have to appreciate the problem. So welcome to the microservice maze.
Just take a look at the contrast here. On the left, you've got the old monolith. Architecturally simple, everything's in one big box. But then, on the right, that's the world of microservices. Yeah, it's distributed and it's scalable, but wow, it's also a chaotic mess of connections. By breaking our application into all these little pieces, we created a brand new headache. How do all these pieces find and talk to each other reliably? That right there is the heart of the microservice maze. Now let's be totally clear. We left the monolith for some very good reasons. It often led to what's called the fear cycle. The application would get so massive that not a single person on the team could understand the whole thing. You'd be terrified to make a change because it might break something completely unrelated. And even a tiny one-line fix, oh yeah, that required a full, high-risk deployment. It was stressful, and it was draining IT budgets dry.
So we broke the monolith apart. And yeah, we solved the fear cycle, but in doing so, we created a whole new set of problems. These are fundamental challenges that every single development team was suddenly forced to solve from scratch, over and over again for every new project.
And this is the result, a recurring checklist of really tough questions. For every new application, teams have to figure out service discovery, resiliency, asynchronous communication, state management. This is what people call undifferentiated heavy lifting. It's essential work that adds absolutely no direct business value, and it's what can grind development to a halt.
But what if you didn't have to solve those problems every time? What if a platform could just handle it for you? Well, this brings us to the hero of our story, Dapr, your application sidecar.
So what is Dapr exactly? At its core, Dapr is a distributed application runtime. Its whole goal is to dramatically simplify the complexity of building cloud-native applications by giving you consistent, proven patterns as simple building blocks.
And it does this using a brilliant pattern called the sidecar architecture. Imagine a dedicated helper process running right there alongside your application. This sidecar handles all the complex plumbing, and your application just talks to it using simple, standard APIs like HTTP or gRPC. And the beauty of this is that your code stays clean and focused purely on business logic.
This diagram really shows the magic. At the top, that's your application code, in any language you want. Down at the bottom is all the complex infrastructure, any cloud, any environment. Dapr is the bridge in the middle. It provides a consistent set of APIs, these building blocks, that completely decouple your code from the infrastructure. Your Python code doesn't need to know it's talking to AWS. It just knows how to talk to Dapr. That's a huge deal.
All right, let's take a closer look at that toolkit. Dapr provides a whole set of APIs for these common distributed system challenges, which it calls building blocks.
First up, service invocation. So instead of your services calling each other directly over the network, they just ask their local Dapr sidecar to call another service by name. Dapr then handles finding that service, automatically retrying if it fails, and securing the connection with mutual TLS encryption. All that complexity is just handled for you.
Next, state management. Need to save some data? Your code just makes a simple API call to Dapr. It doesn't know or care if the backend is Redis, Cosmos DB, or something else. This means you can swap out your entire database technology without changing a single line of your application code. I mean, think about that. That's a massive leap in portability.
For building those event-driven systems, you've got the publish and subscribe block. This lets services communicate asynchronously without even knowing about each other. One service can publish an order received event, and other services can subscribe to it. This decoupling creates incredibly resilient systems, and again, your code has no idea if the message broker is RabbitMQ or Azure Service Bus.
And finally, bindings. This is all about connecting to the outside world. A binding can trigger your code whenever. Say, a new tweet matches a keyword, Or it can let you send an SMS through Twilio with a simple API call. It makes integrating with all these external systems incredibly straightforward.
Okay, that all sounds great in theory, but let's see how this actually transforms a real-world application. We'll take a look at a sample highway traffic control system. So here's our application before Dapr. Notice all those direct HTTP calls chaining from one service to the next? This creates a really tightly coupled system. If the find collection service has even a momentary glitch or is down for maintenance, the traffic control service call will fail, and that failure just cascades all the way back. The system is incredibly brittle.
And here is the transformation. Just look at how the direct calls are gone. Now the traffic control service simply publishes a message using Dapr's pub/sub block. The find collection service subscribes to that message, completely decoupled. We're using Redis for state management and a secure, resilient service call to the registration service, and it's all orchestrated by Dapr's sidecars. The services themselves are now simpler, and the system as a whole is vastly more robust.
So, to just summarize that transformation, we went from fragile, direct calls to robust pub/sub messaging. We went from losing all our data on a restart with in-memory state to durable, pluggable state stores. And we went from hard-coded dependencies to dynamic service discovery. That's a huge win.
So what does all this mean for you, the developer, and for the business? Well, it means you get to develop faster, not harder. This right here is the ultimate payoff. You get to spend your time writing code that actually matters to the business, not boilerplate infrastructure code. Your applications become truly portable, free from cloud vendor lock-in. And your team can move faster because they're all using one consistent set of APIs for everything. The result is faster development and a massive reduction in the long-term cost of maintenance.
And hey, don't just take my word for it. As Mark Russinovich, the CTO of Azure, says, developers want to focus on business logic and let platforms handle the rest. This is exactly the problem that Dapr was built to solve.
Dapr offers a clear path out of the microservice maze. It's a way to finally realize that promise of agility without drowning in all this accidental complexity. So the real question isn't just about escaping the maze, it's about what you're going to build once you're free.